By the time Ajax and jQuery reshaped the frontend, the internet itself had changed. Users were now expecting real-time dashboards, live chats, instant notifications, and collaborative tools. The kind of experiences the early web stack was never built for. The frontend was evolving fast. The backend didn't. Languages like PHP, Ruby, Python, and Java powered the 2000s, but they were designed for a world of simple request-response pages. As soon as the web became more dynamic, traditional backends ran into major limitations. For example, real-time experiences require a persistent, two-way connection between client and server. This means WebSockets, persistent, and bidirectional. But traditional backend stacks relied on short-lived requests, blocking I/O, and one thread per connection. They assumed that user clicks, server responds, and the connection closes. But real-time apps needed event-driven architecture, non-blocking I/O, and persistent sockets with zero waiting time. There was also another limitation of these traditional servers, and that was concurrency. In most traditional runtimes, one connection equals one thread. That means that if a user uploaded a file, the server stayed frozen until completion. Multiply that by thousands and servers collapsed. What modern apps needed was a model where one thread could manage thousands of concurrent I/O operations through events and callbacks, not thousands of heavyweight threads. So while building a file upload system using Ruby, Ryan ran into the same concurrency issues. Blocking I/O forced servers to sit idle while waiting. He noticed something interesting. JavaScript in the browser already used an event-driven, non-blocking model. The event loop kept the UI responsive while background operations were in progress. The problem? Well, JavaScript lived inside browsers. It couldn't run on backend code. And then a breakthrough arrived. Google Chrome introduced V8, an insanely fast JavaScript engine built to optimize asynchronous operations. It had a high-performance event loop, just-in-time completion, non-blocking architecture, incredible execution speed, and an open-source license. Ryan connected the dots. Instead of fixing PHP or Ruby, what if the backend used JavaScript, the same event-driven model that makes the browser so fast? It sounded ridiculous. It sounded radical, and yet it was the right idea. Ryan pulled V8 out of Chrome, embedded it in C++, and then added everything JavaScript was missing: file system access, networking APIs, timers, a module system, and even updated the event loop. And this new creature came to life. Node.js, the N in the PERN stack. It wasn't just a library. It wasn't even a framework. It was a runtime, a new environment where JavaScript could run forever outside the browser, handling files, servers, and asynchronous I/O at a massive scale. From there, JavaScript basically went from that pop-up language to the most important language on the internet, and soon enough, the most important language